Okay, hi. Today we're going to look at transformations of the function y equals f of x. So here I have a function y equals f of x, and we're going to look at doing some translations. First, I want to go over what some of these translations are. We'll start with vertical, and when we have a vertical transformation, when we have f of x plus a, we're going to move up a units. F of x minus a, we're going to move down a units. If we add or subtract the a inside the parentheses, we're going to move left or right a units. Sometimes these look like they're opposite because you're adding a and you're moving to the left a units. But when I get to the picture, I'll kind of give an example of why we would move to the other side, where this one we go up and down depending on the plus or the minus. A vertical stretch, that means we're going this way and we're stretching it out. We're going to, for purposes of what we're going to be doing, we're going to leave the x value alone and we're going to multiply the y value by a to stretch this graph out. For a horizontal shrink, that means we're taking it and we're going to shrink it this way. We're going to leave, when we have multiply, we're going to multiply a inside the parentheses. We're going to leave the y alone, but we're going to multiply the x by a, and we'll see that this either takes the graph and shrinks it and compresses it this way, or it stretches it out really long. So let's take a look at an example. I have here y equals 2 times x times f of x, sorry about that, times f of x minus 3 plus 1. And what we're going to be doing for this one is we're going to take y equals f of x and we're going to do the necessary transformations with this one right here. So we are going to start with, I always say that the best way to do these is to start with inside out. So we start inside and then work our way out depending on what we're doing to that function. So we're going to start with minus 3 inside the parentheses of 2 f of x minus 3 plus 1. Okay, so in order to do that, we're going to go to this rule here, and we're going to see that we're going to shift this horizontally a units. Since this is a minus 3, we're going to shift it to the right a units. The reason you can think about it going to the right is if we plug in a number for x, like 3, positive 3, we're going to get 3 minus 3 is 0. We know that f is 0 lies on the x-axis. So that's how we're going to, that's kind of like our back to the origin idea. So in order to make this 0, we would have to add 3 to it and go to the right. So we're going to do that to this graph, and that'll be our first step to doing this. So I'm going to take every point and I'm going to move it to the left, to the right 3 units. So we're going to take this point here and move it to the right 3 units. So 1, 2, 3, and we're just going to draw that point right here. So we didn't do anything to the y value, we just moved the x value over 3 units. We're going to do the same for each of these points. Move this over 3, this over 3, this point over 3, and this point over 3. And then we're going to connect these. And I'm going to go ahead and say this is step 1. And what we've done is we've graphed y equals f of x minus 3. So now what we're going to do is we're going to graph the next step, which is the next part of the inside out, in this case, the 2. And we look over here, and this is a vertical stretch. So what do you do in this case? You're going to leave the x value alone, and you're going to multiply the y value by 2. So we're going to go to this point here, and this point has an x value of negative 2. Well, we're going to leave the x values alone, so we don't care about the x value. What we're really worried about is what this y value is. This y value is at 1. Use my drawing here, should be a little bit better. Okay, it's at 1. So we're going to take that y value and multiply by 2. So 1 times 2 is 2, and we're going to keep that x alone. So this x is at 2, y is at 2, that point goes right there. Notice here that this y value is 0. So 0 times 0 is 0, or 0 times 2 is 0, so we're going to leave that point right there. This is y is equal to 2. X is 3. Well, we don't care about the x, we're just worried about multiplying by the y, multiplying the y. Since the y is 2, we're going to multiply by 2 and we're going to get 4. So this x stays the same. We're going to stretch this out to 4. This is going to be also the same, and we're going to stretch that out to 4. And this point here is at negative 2. We're going to stretch that down to negative 4. But the x values stay the same. If you connect these, you'll notice that what we did is we took this original graph, the red one, and we stretched it out. So that's why we say that's a vertical stretch. So this is the graph of y equals 2, f of x minus 3. The last thing we're going to do, again, we're going to go inside out. So we started inside, we multiplied by the 2, then the next thing we're going to do is add 1. When we add 1 outside, we're going to take and go up a units. So we're going to take everything and we're going to go up a units. So we're going to go to this point, and we're going to move that point up 1 unit, which is right there. This one we're going to move up 1 unit, so it's going to be here. This point we're going to move up 1 unit, here, up 1 unit. And this one, up 1 unit to negative 3. And then we're going to connect it. And that is going to be our graph of y equals 2f of x minus 3 plus 1. And we've done this in a step-by-step fashion. So we've taken our original function. We took the first step, which was subtracting 3 inside the function, which allowed us to shift horizontally to the right a units, which is in this case 3. Then we stretched it by 2. Remember, when we multiply outside, we're going to multiply the y values but leave the x values the same, stretching it vertically. And then we add 1. I will put up another video in which I'll do another example. And in the next example, I will do a horizontal shrink and also do a rotation about the x-axis or about the y-axis. Y-axis, x-axis, okay? So that'll be coming up soon, but that's it for this one. Thanks.